Hey everyone, so in this screen recording, I'm going to show you two things. So one thing is how to do an network hijacking and man in the middle in the cloud by controlling the DNS and private CA by using the this service, acm-pca. And I'm going to show you the bug that we have discovered in AWS that allows to hijack the network communication to the AWS APIs. So for the demonstration, let's assume that we have been able to taken over the following role. So it allows us to manage the DNS in route53 by creating hosted zone and changing the records, and allows us to have some permissions in the AWS certificate manager private CA, private certificate authority service, which allows us to like issue certificates using the AWS private CA. So and describe VPCs for describing VPCs. So as you can see in route53, we do not have we have one hosted zone, but that's not important for now. And we would be using the following environment. So this is going to be our victim, 224. And the victim would be like simulating the web app, which has some private CA in the trust store already. It's because for some internal communication they use private CA, so it's been trusting the private CA that is hosted in acm-pca, so in this service. I'm gonna to show you an PCA. Yeah, certificate manager. Create private CA. Yeah, this private CA. So we've got private CA here. It's gonna be trusted. It's in the trust store of this instance, and we are going to hijack the network communication to the AWS API using this instance, which has the route53 simulations role that I have shown you. So let's get started. Yeah, in here we are get caller identity. AWS STS get caller identity. We are route53 simulations. In here, it doesn't matter who we are, but we would be running the one of the code examples of the secrets manager that executes some tests in the secret manager. So calling secrets manager. And we have this root CA here, which is the this CA. That's it. It is stored already in the Java Trust store, so Java would trust it. So now what we do in here, let's assume that we have already generated a private key and CSR for the host. But now what we do for just for the testing purpose is we create hosted zone for secrets manager, and this is exactly the bug in AWS. So let's change this thing here. So we would try to create a hosted zone in our VPC in this region. For now, let's create hosted zone for Amazon AWS and see what happens. Yeah, we're getting an error. It's because Amazon AWS.com is reserved by AWS, which is exactly what we meant. So, which is exactly how it's supposed to behave. So let's try to create for US East 1. Same error, US East 1 is reserved by AWS. And now what we do is create for secrets manager. Yeah, and it has been allowed. So this is the bug in AWS. So it pretty much doesn't allow us to create a hosted zone for Amazon AWS.com or US East 1 Amazon AWS.com, but it allows us to create a hosted zone for Secrets Manager US East 1 Amazon AWS.com. which basically would allow us to hijack the network communication to secrets manager. So now we've got a hosted zone. So let's do an what we want to do. We want to yeah, we will be changing the resource record using the man in the middle payload in the secrets manager hosted zone. So we grab this ID, put it in here, execute. Change batch is required, yeah. No hosted zone found. Oh yeah, it's yeah, and the change happened, and our change is that we set the secrets manager US East 1 Amazon AWS.com to our host. We are this host. So now when we set up the listener, let's do sudo encat sudo encat nlpp for free. When we set up the listener, and in here, when we do AWS secrets manager list secrets, we've got a connection. So yeah, but as you can see, it's TLS encrypted, so we cannot see the payload. However, when let's say that our application, so this is Java, uses the some private CA, which is in the trust store, we should be able to hijack this communication. So what we do in here now is we would use the not get certificate, but issue. Yeah, we will call acm-pca API to issue a certificate for us with the certificate authority ARN, which is trusted, is this one. It is already in the trust store of our target Java application. And we provide a CSR, which is our CSR, which we previously already generated using OpenSSL. And yeah, let's do that. As you can see, the certificate was issued. Here is a certificate arm. So we would use get certificate. ACM. Yeah, let's use get certificate. Okay, let's copy this arm. And here's our certificate. We've got a certificate chain and certificate. So let's copy that. Nano cert. Let's modify that. Yeah, we need to modify that because it has some /n instead of the new line. And we've got now cert, we've got private key. So what we do is we do this cert. So we set up the listener with our cert and private key, and let's see it. Now let's run some tests, and let's see what happens. So we simulate an web app traffic by using Java, AWS SDK to access Secret Manager. As you can see, test one passed, and we see the payload. So now we can use this payload, send it to VPC endpoint of Secrets Manager, and that way, I believe in here it was a secret created, so create secret code. But anyway, anything can be hijacked that way. So we can do a full man in the middle in the cloud. Yeah, that's it.